So hello guys, welcome to my channel. In this lecture we will discuss about linear combination of atomic orbitals, which is called LCAO, by me Shankaraj Sarkar. So this topic is included in our class 11 syllabus, and it is from chemical bonding chapter. Okay, so we will start now. So what is linear combination of atomic orbitals? Basically, atomic orbitals gets combined to form molecular orbitals, and those molecular orbitals are uh, are basically explained with the help of this concept, which is called linear combination of atomic orbitals. So suppose psi A and psi B. Suppose psi A and psi B represent amplitude of the orbitals of the atoms A and B respectively. So this is suppose psi A and this is the psi B. So we know that psi A and psi B are atomic orbitals which can be represented by electron wave. So electron is moving like this, and it is psi A and it is psi B. So when psi A and psi B will have constructive interference, so that their resultant wave has the amplitude psi A plus psi B, then it is called constructive interference, and it is formed by addition of psi A and psi B, right? Now if psi A and psi B undergo subtraction, those if they undergo subtraction, they will form a uh, destructive interference. So for destructive interference, they will have a structure like this. Okay, so for that they have to undergo subtraction. So remember one thing, in destructive interference, the in the destructive interference, what happens, the phase of the amplitude wave are not same. Okay, so they just undergo subtraction, and as a result they form a wave whose amplitude is equal to psi A minus psi B. So when the two waves are in phase, the amplitude of the new wave is called phi, which is equal to psi A plus psi B. And when the two waves are not in phase, the amplitude of the new wave is called psi dash, is equal to psi A minus psi B. So note that the molecular orbital formed by the additive effect of the atomic orbital is called bonding molecular orbital, which is in short is called BMO, and the molecular orbital formed by the subtractive effect of the atomic orbitals is called anti-bonding molecular orbital. So formation of BMO and ABMO can be explained with the help of this structure. So suppose psi A, this is psi A and this is psi B. These two are from different atoms. Okay, so they will undergo constructive interference and they will form BMO. So when it is BMO, you can write psi phi is which is equal to psi A plus psi B, and when they undergo destructive interference, they will form psi dash, which will be equal to psi A minus psi B, and they will ultimately form ABMO, means anti-bonding molecular orbital. Suppose psi A contains only one electron and psi B also contains one electron. Okay, so after forming the molecular orbital, they will give one electron each from each of the atomic orbitals, and obviously this box will be filled. So remember one thing, the in this direction the energy will increase. Okay, from here to here energy will increase, and this is the atomic orbital, and this is the atomic orbital of A, it is the atomic orbital of B, and since the BMO has lower energy than the atomic orbital, so this means that the one BMO is more stable than the atomic orbital. Okay, and ABMO is unstable than the energy of the atomic orbitals taken. So remember one thing, this BMO, this direction, see this dotted lines, the energy of the BMO is less than that of atomic orbitals, and this part delta is called stabilization energy, and this part, which is from atomic orbitals to ABMO, is called destabilization energy. So remember one thing, the higher the stabilization energy, higher the gap, that means higher will be the stability, and higher this gap means this delta dash means that it will be more unstable, or you can say destable. That's why it's called this is more destabilization energy. All right, thank you for listening, and all the best for your exams.